Chris Kaffer from Mallinda, and this is a here on behalf of a program that's Cyclotron Road at University he's from UC Berkeley, but it's out at Lawrence Berkeley National Labs. And this program gets to a broader question that says we have 17 national laboratories in the country. What are we doing to make it so that our national labs can partner more effectively with people that want to start companies, new technology-based companies that ultimately become that next generation great manufacturer out there? But they're really at this point where they've got a research idea somewhere and they're just taking that first step to starting a company. How do we wind up using that national lab ecosystem in a way that it raises their batting average, right? If we can increase the batting average of those companies, we're not going to be able to, they're responsible for getting there themselves. But how do we wind up using that ecosystem in a way, and that capability, the scientific resources, that innovation capability, so that you can open it up and they can get there further faster? So we have these lab-embedded entrepreneurship partnerships. We piloted it beginning in 2014 out at Lawrence Berkeley National Laboratories. In our second cohort this past year, we wound up, it's when Mallinda wound up joining us. So with that, turn it over to Chris.
Thank you, Mark. So again, my name is Chris Kaffer. I'm the CEO and co-founder of Mallinda. And at Mallinda, what we're doing is we're developing lightweight advanced composite materials for the automotive segment that significantly improve the economics and the throughput of composite manufacturing. And so at Mallinda, what we envision and what gets us jazzed and what gets us up in the morning into the lab every day is this notion that we really believe that we can completely transform the transportation segment, where fuel efficiency and range are improved not by completely redesigning a combustion engine, but merely just replacing legacy materials like heavy metal alloys to improve the power-to-weight ratio in our vehicles. And we're really doing this, what's cool about our technology is that we're really doing this in a closed loop and cradle-to-cradle system. So just real quick for, I think composites have been thrown around here like a million times today. For those of you not familiar with composites, you can really think of a composite, especially in our case, as a strong reinforcing fiber like carbon fiber or fiberglass that's held together with just a strong plastic glue, right? And so composite technologies are really interesting because they're 50% lighter than steel typically, 40% lighter than aluminum. And so if you can replace some of those materials in cars, we can improve, like I said, fuel efficiency, range in the case of EVs, reduce greenhouse gas emissions. So with these benefits, why is it that the automotive industry is lagging and not necessarily adopting these technologies? So one of the reasons that they're not adopting these technologies is because the current methodologies for making composite materials are just too long, right? The cycle times are far too long. They can take anywhere from tens of minutes to hours, and for high volume, high throughput manufacturing that's demanded by the automotive segment, you have to have faster cycle times. So our technology improves cycle times because we're making composite parts in an analogous manufacturing protocol to sheet metal fabrication, right? So if you guys have seen those videos where they take a piece of sheet metal, they throw it in a hydraulic press, they push the button, stamps out the part, they move on to the next one. That's really what we're developing. So really, I think I'm here today to give you some insights into the challenges of building a hard manufacturing technology company, and how the Cyclotron Road program in Berkeley is really supporting us. And so I think Mark briefly mentioned, but for those of you not familiar with Cyclotron Road, it's a DOE-supported incubator that provides supports for innovators developing really potentially groundbreaking and impactful energy technologies. So they bring in about 6 companies a year, and they support these companies for 2 years by embedding us in the national laboratory, where we can leverage the physical and intellectual assets of a world-class research institution to significantly accelerate our technology development. And it's really founded on this premise that there are all these entrepreneurial researchers out there, all these really great technologies, but there's just no home to actually develop these technologies. And so why is that? So I think it's instructive to kind of give you some of our our metrics, right? So where we're at today. So we founded our company. We're University of Colorado Boulder spin-out. So we licensed technology from the university, which is a story in and of itself, in April of 2014. Since April of 2014, we've completed prototype development. We're currently in the process of scaling. We've raised $1.7 million in non-dilutive funding. It's not much, but in the last 6 months, we've sold $20,000 worth of research materials to companies that are interested in our technology. We're currently in an evaluation process with a $77 billion company on a joint development agreement. I have an MOU from a $60 million US branded sporting goods company to develop a line of protective soft goods. We have a team of 6. Sounds pretty awesome. We cannot get investment, right? So why is that? Why is it really challenging for companies like ours to find private investment? So, often the type of stuff that we work on is defined as hard tech, right? Hard tech companies aren't just hard to build because they have hard science underpinnings. They're hard because of the unique challenges in pulling together all the things that we need to do to actually do technology development. So first and foremost, to do hard technology development, to build prototypes, I can't just have a laptop in a co-working space or my mom's couch, right? Like, I need access to the infrastructure that a world-class research institution can give me. So if you think about it, there's significantly high costs of R&D from facilities to instrumentation, right? So I think it's been mentioned here a little bit even about payroll. So for companies like ours, we have a very highly skilled workforce, right? So with advanced degrees, they have very high BLS minimums for their salaries, and it's hard to pay for those people. And I should mention, we went through a funding gap where an 8-month funding gap where we had to scramble to get money from friends, family, aunts, uncles, $60,000 just so we could make payroll for a few of our employees. Of course, we need lab infrastructure. We need a wet chem lab. We need hazmat. We need chem certification, safety, all these sorts of things. And then, of course, we need laboratory equipment. So we need access to equipment that costs tens of thousands of dollars, and in some cases, hundreds of thousands of dollars. These are things that you cannot purchase with government grants. The government grants that we've had to support us actually put a limit on capital equipment of $5,000. So that's really where we're finding the value at the National Laboratory. The second real challenge is technical risk and market risk, right? Private investors can typically take one of those. They can't take both. And hard technology companies have significant levels of both market risk and technical risk, and with very long validation cycles, right? So the Ford F-150 all aluminum frame body, right? So all they're really doing, this is my characterization, is replacing steel with aluminum, right? An analogous metal. It took over 10 years and $1 billion of development to get to replacing steel with aluminum. That is simply not possible for a startup company to get that kind of money and to have that kind of development timeline. So private investors like VCs, right? They have a fund cycle. It's 10 years. So hard technology development with long validation cycles don't fit neatly into the VC model of financing. And if you look at VC financing in hard energy technologies over the last 8 years, there's been a massive reduction. So that's where the Cyclotron Road program really comes in. It's filling these gaps in funding gaps from institutional investment for hard technology companies. So I think I'll actually just kind of wrap this up so we can have some time for questions and for panel discussion. I just want to tell you conclude with what it means for me personally. So Cyclotron Road gives us the best opportunity to build our technology. So I mentioned we spun out of the University of Colorado. I still live in Colorado. We have a laboratory there. I fly out every week, Tuesday through Thursday, at my own expense, because I can't pay for that with our grants, to be working at the national lab and to be in that environment. And for me personally, it's challenging. I have a 2-year-old and a 4-year-old at home. It's also very challenging for my wife, obviously. But those are the sacrifices that we're making because there's nothing like this that gives us an opportunity to make it. And that's it. Thanks.
Great. Thank you, Chris. So, we're going to move on to question and answer here in just a couple of minutes. I'm going to get going on some dialogue. But the first thing I want to point out, first of all, that hopefully everyone got a sense that there's tremendous opportunity for innovation in the manufacturing sector right now. Whether you're looking at legacy industries that are really reinventing themselves to maintain competitiveness, whether you're looking at small businesses, large businesses, early startups, universities, there's a lot going on right now. And what we hope to do within our program is to continually connect those groups together, right? The focus is that science and technology innovation. That's what we wind up doing. That's how we're driving that innovation out there. At the end of the day, it's a research and development question that's being asked. But there are new research and development questions that are asked relevant to manufacturing problems. I love the fact that we're sitting here with people working in both composites and steel, that they're trying to drive towards the same endpoint. And we're driving science and technology innovation, so at the end of the day, one of them winds up moving forward in that area, or both of them move forward in that area. That's fine. But by connecting all that research and development in the United States to manufacturers in the United States, we make sure that manufacturing winds up happening here.